So here I have triangles, and again, triangles are another basic shape in geometry that you'll be seeing. So just to give the picture really as such, as we all know, triangle something like this, right? This would be a triangle, and one of the main properties is that the sum of all the interior angles within the triangle add up to 180 degrees. And so this is an important concept because, for instance, if we're given something like this angle being 80 degrees and then this angle being 20 degrees, well then automatically this one must be 80 degrees. And so you can find a different measure. Now, for instance, if, let me just raise this. Now, for instance, if you're given something like, if you're given that this measure here is 160 degrees, right? Then you know that this is a straight line, obviously, and the straight angle is 180 degrees. Therefore, this must be 20 degrees. Clearly, if this is 20 degrees, the sum of these two angles must be 120 degrees. Therefore, this indicates that with reference to one interior angle, its corresponding exterior angle is equal to the sum of the other two interior angles. So in this case, the exterior angle to this interior angle of 20 degrees is 160 degrees, and the sum of the other opposite facing interior angles is also 160 degrees, because 180 minus 20 must be 160, therefore the sum of these two angles must be 160 degrees. Again, a triangle is a shape that has three angles and three sides, as we can see here. And now there are different types of triangles, right? So uh, with the three main types I'll be going over with are equilateral, right? Equilateral. Then we have isosceles, and then we have scalene. And so with the equilateral triangle, it's a triangle it's a triangle with three sides that are all equal in length in all angles that are equal as well, or congruent. And if all three angles are congruent, we know that the triangle has a sum of 180 degrees among its interior angles, then we know that each angle must be 60 degrees. So this one's 60, this one's 60, and this one's 60. Right? And all the sides are also equal in measure. Now with the isosceles triangle, it states that at least two sides must be equal in length. So technically, if you're looking at this one, this can be classified as an isosceles triangle just because it has at least two sides that are equal in length. However, it's better to classify this as equilateral just because it's a specific type of triangle that has all three sides being of equal length. So with an isosceles, we know that it's at least two sides are equal in length, so something like that. And this one may not. So if we're given that this is, for instance, 80 degrees, really we can compute these two angles. And really with triangles, we see that you're subtracting 80 from 180 and you get 100 degrees. So you know that the sum of these two angles must be 100 degrees. The fact that this side and this side are equal indicates that these two angles must also be equal. Therefore, each angle must be 100 divided by 2, which is 50 degrees. Therefore, this is 50, and this is 50 as well. And adding them, you get 180 degrees. Now, with a scalene triangle, we see that this is, I wouldn't say it's erratic, but it's just different in the sense that all three sides are of different length, and therefore all angles would be different. So this is A, B, C degrees. So you would see that all three sides and angles are different in measure. Now, these are again how you would classify triangles. Of course, there are other ways to classify them in terms of their angles. But before I go over those, I just briefly want to tell you about special cases of triangles that exist. And so these are also pretty important. So here you will see that for instance, if I have a triangle that's 90 degrees here, this is 30 degrees, and this is 60 degrees. The thing with this is that if you know the measure of something, technically I haven't drawn this correctly because this side is supposed to be shorter than this side. You get the point, because the side opposite 30 degrees and the side opposite 60 degrees, well, the side opposite 60 degrees should be longer. But just assuming that this side is longer than that side, and obviously the side that's opposite the right angle is the hypotenuse, so this is of course the longest side. So we know that. Now we're looking at this, and really this is just a special case, I guess you would say. It's a special case of a triangle. The side that's opposite the 30 degrees is x. The side that's opposite 60 degrees is x times root 3. And the side opposite the 90 degrees is 2x. So this is a rule that's really applicable. So you may be given any value. For instance, let's say that you're just given this triangle. And so we may be given that this is 5. And we have to compute the lengths of the other two sides. Now we know that x, which is this, right? X times root 3 must give us 5. Therefore x is equal to 5 divided by root 3. That's this side here. And because we want to rationalize the denominator, again, we multiply this by root 3 divided by root 3. So we can get the radical out from the denominator. This gives us 5 root 3 divided by 3. And so that's the value of x as we know now. And just we know that this is x. Therefore, when we look at this, the side that's opposite 90 degrees must be 2 times the side that's opposing 30 degrees. Therefore, the hypotenuse in this case would be 2 times this value, which is 10 root 3 divided by 3. And so essentially we have found all the sides of this triangle. Now there's another special case that I'll be going over, and it's a 45, 45, 90 triangle. So here's the triangle. That's 90 degrees, and the fact that, I mean, it's a 90, 45, 45. Well, if these are 45 and this is 90, this indicates that these two side lengths must be equal, and of course this is the longest side. And so really, if we were to state that the side opposite the 45 degrees is x, it would make sense to state that the side that's opposite this 45 degrees is also x. And what happens is that knowing that these two are x, what the rule states is that the side that's opposing the 90 degrees must be x times root 2. So that's the basic idea here. So really, if we're given anything, we can just find the length of the hypotenuse here. So say we knew that this is a triangle and that x is 5, or we're given that the side opposing one of the 45 degrees is 5, we know that this is also 5, and then this must be 5 root 2. So this one's a pretty easy one, and it's an isosceles triangle, as you can see, because two sides are of equal length, and the angles that oppose these two sides are also equal, being 45 degrees each. So these are the special types of triangles. Now, there are also some classifications based off the angles that are within the triangle. So for instance, if you see an acute triangle, right? An acute triangle. So really this is the one that all angles are less than 90 degrees. So you have an angle where all are less than 90 degrees. And so if you have something that's 60 degrees, 60 degrees, 60 degrees, you know that this is an equilateral triangle because all of its sides must be of equal length, but you also know that it's an acute triangle just because each angle is less than 90 degrees. Therefore, you could classify this as an equilateral triangle that is acute. But again, this is an acute triangle. Now, if you go with a right triangle, we know that the right triangle is one that has a right angle here. So this is a right triangle here. So it has a 90 degrees here, and just needs to, obviously, it can only have one right angle. And moving on to the third classification, we have an obtuse triangle. And so if we think about this, again, it cannot have two angles that are obtuse. That's not possible because then the sum of the angles would definitely be over 180 degrees. Therefore, it has an angle, one specific angle that is more than 90 degrees. For instance, it could be something like this being, I don't know, this being 150 degrees, and this one could be 20 degrees, and this one could be 10 degrees. So again, that would be an obtuse triangle. And now when you're finding the perimeter of any of these triangles, you're just adding the side lengths of the triangle. And in order to find the area, we really just do base times height divided by 2. So if we know that, for instance, this is 5, right? And if this is 8, the area of this triangle would be half times base times height. Half times 8 times 5 gives us 20 units square. So the area of this right triangle is 20 units square. However, this one's an easy case just because we have a right angle that's given here, indicating that the height is perpendicular to the base. However, in a case like this, it may not be that simple. Although we may know the measure of this, for instance, let this be 10, you can't really multiply this by this because it's not the height. The height of this triangle would be a line that you have to draw that is perpendicular to the base. So we need to find this value and then multiply that by the base and divide the outcome by 2 to determine its area. And obviously in later videos and lessons, I'll be going over different problems and exactly how to find their areas and perimeters. So thanks for watching.